Some landscapes whisper stories of the ancient past. Others shout them from titanic stone ramparts. There are places on this planet that defy belief, that look more like the set of a fantasy epic than a part of our world. These are the places that grab you, that stop you in your tracks and force you to ask, how? How is this even possible? Before us stands one such marvel. A colossal spine of rock like the armored plates of a sleeping mythological beast rising from the earth in a jaw-dropping display of natural architecture. It looks impossible. A series of gigantic triangular blades aimed at the sky. What colossal forces could sculpt the earth in such a way? At first glance, the sheer scale and complexity can be baffling. It's easy to feel small and simply accept it as a mystery beyond our grasp. But the beautiful thing about our planet is that its greatest secrets are not locked away. They are written in the very stone at our feet, waiting for us to learn their language. And together, that's exactly what we are going to do. We will become geological detectives, piecing together the clues to unravel the spectacular story of these stone titans. If you find yourself captivated by the grand mysteries of our planet, and you love to explore the how and why behind its most stunning features, then you're in the right place. Take a moment right now to subscribe and turn on notifications. Every video is a new expedition, a new puzzle to solve, and by joining our community, you won't miss a single discovery. Your support helps us venture further and bring these incredible stories to light. Now let's begin our investigation. To understand a grand structure, we must first look for a repeating pattern. The universe, from the spiral of a galaxy to the veins on a leaf, is full of rhythms and patterns, and the forces that shape our world are no different. Look here in a landscape just a few miles away from our primary wonder. What do you see? At first, it might just look like a series of hills and valleys, but look closer. Notice the spacing. Of the main channels, the small canyons carved by water over millennia. There's a certain regularity to them, an almost predictable interval. Now, look even closer at the smaller drainages that feed into these main channels, like tributaries joining a river. They too exhibit a surprisingly uniform spacing. This isn't a coincidence. This is the signature of water. Water is a relentless and efficient artist. It seeks the path of least resistance, and over immense timescales, it organizes itself into efficient networks to carry away sediment. This creates a kind of rhythmic dissection of the land. We see this pattern all over the world. Along the flanks of great mountain ranges, we see immense valleys carved at strikingly regular intervals. In desert badlands, intricate networks of miniature canyons create a mesmerizing, repeating geometry. This observation is our first major clue. It tells us that these formations are intimately linked to the systematic patterned work of erosion, specifically by water. The regular spacing of the fins is not random. It is the logical outcome of a landscape being methodically carved apart. So, we've identified the tool erosion. But that doesn't explain the incredible shape. Why here? Why do they look like giant triangles? That brings us to the next and most crucial part of the story. Let's zoom in from the landscape scale to the rocks themselves. Imagine a time hundreds of millions of years ago. This entire region was a vast, shallow sea. Over eons, sediments settled on the seafloor layer by layer, like pages in a book. Some layers were formed from fine-grained mud and silt, creating soft rock we call mudstone or shale. Other layers were formed from the shells and skeletal fragments of marine creatures compacting over time to form hard, dense limestone. Or perhaps it was a sandy beach, which would become a tough sandstone. So now we have our book of stone, with alternating pages of hard and soft rock all lying flat. But the Earth is not a static place. Tectonic forces, the unimaginable power of shifting continents, began to compress this region. Imagine placing your hands on both ends of a stack of paper and pushing them together. The stack would buckle and fold upwards. The same thing happened here, but on a planetary scale. Those once flat layers of rock were tilted, bent, and thrust upwards at a steep angle. In this case, a dramatic 50-degree. This is our second critical ingredient: steeply dipping layers of rock. So, Now we have the scene set. A massive ridge of rock layers tilted at a steep angle, standing exposed to the elements. And crucially, these layers are a sandwich of alternating hard and soft materials. Now, let's reintroduce our sculptor. Water. Rainfalls. Streams begin to form, and they start to carve into this tilted wall of rock. Where will the water have the most success? It will attack the soft layers, the weak shells and mudstones. These layers crumble easily. They are washed away with relative speed, and the water carves deep, narrow V-shaped canyons directly into them. Meanwhile, the hard, resistant layers of limestone or sandstone stand their ground. They are like the bones of the mountain. They resist erosion far more effectively. So, as the streams carve deeper and deeper valleys into the soft layers, what happens to the hard layers in between? They are left behind. They are left standing proud as towering ridges between the ever-widening canyons. The pattern of erosion we saw earlier, the rhythmic spacing of valleys, is now being guided and controlled by the underlying geology. The valleys form in the soft rock, and the fins are what remains of the hard rock. And that brings us to the final piece of the puzzle, the iconic triangular shape. Why aren't they just straight vertical walls? This is where we have to think in 3 dimensions. We have a hard layer of rock tilted steeply into the earth. On either side of it, a V-shaped canyon is being carved into the softer rock. The top of the hard layer forms the sharp, sloping ridgeline. That's the top edge of our triangle. The sides of the triangle are not true sides of the rock layer itself. Instead, they are the V-shaped cross-sections where the canyons on either side have sliced into the hard layer. As a canyon cuts deeper, it also widens at the top, creating that classic V-shape. Where 2 of these expanding V-shaped canyons, one on each side of the hard ridge, meet, they form a pointed triangular face. That is our formation. Geologists have a wonderfully simple name for them, flat irons, because they look like the old, heavy irons used for clothing. Each flat iron is a testament to this perfect combination of ingredients. Steeply tilted layers, a dramatic contrast between hard and soft rock, and the relentless, patient carving of water over millions of years. The scale of a flat iron can also tell a story. Here, we can see several smaller, more subtle fins. They're trying to form, but they aren't as dramatic. Why? Because the difference in hardness between the rock layers isn't as extreme. The soft layer is still somewhat resistant, so the valleys can't be carved as deeply, and the fin doesn't stand out in such bold relief. But then look further back at that magnificent giant fin dominating the skyline. There the contrast is at its maximum. In front of it is an incredibly soft, crumbly red mudstone that erodes us away like dust. Behind it, another soft layer. But the fin itself is a thick, massive bed of ultra-resistant limestone. At this larger scale, with such a dramatic difference in rock strength, erosion can sculpt a true masterpiece. It creates a colossal fin that commands the landscape. So, what we are truly seeing is a story written in contrast. The bigger the difference in strength between the layers, the more spectacular the flat iron. So, let's step back and look at this landscape one more time. It is no longer a confusing, impossible structure. It is a story written in the language of geology that we can now read. We see the evidence of ancient seas in the limestone. We see the immense power of tectonics in the 50-degree tilt of the layers. And we see the patient artistic hand of millions of years of rain and flowing water in the perfectly spaced canyons, and the beautifully sculpted triangular faces of the flat irons. What once seemed like a fantasy landscape now reveals itself as a logical, albeit breathtaking result of understandable processes. It's a powerful reminder that the world around us is an open book filled with incredible tales of deep time, immense force, and natural artistry. All we have to do is learn how to look, to be curious, and to piece together the clues that are all around us, waiting to be discovered. Thank you for joining this exploration. Until next time, keep your eyes open and never stop asking why.